Welcome back. This question was asked by MIT Integration B in the year 2019, and this is question number 13. And we know that e and log gets cancelled. Okay, this can be written as integral e raised to log of this x raised to 1 upon log x. Why? Because e and log gets cancelled. Okay, into dx is equals to, okay, limit is from 0 to e. Okay, and by law property we can bring this down over here. Why? Because log of a raised to m, where m is greater than 0, is same as I can bring over here m into log of a. Okay, therefore this is same as integral e raised to, here I can bring 1 by log of x into, we have this, okay, log of x. Okay, we have log of x. Okay, and this log x gets cancelled. Limit is from 0 to e, dx equals to integral e raised to 1 is same as e, 0 to e. Okay, dx. Since e is constant, so what we have is same as integral of this is same as e into x. Limit is from 0 to e, upper limit minus lower limit, instead of x, e into e is e square minus 0, therefore e square. Okay, so e square is the answer for this. Welcome back. This integral was asked by MIT Integration B in the year 2019, and this is question number 11. So this we need to apply. From now we have cos of a twice cos a into cos b equals to cos of a plus b plus cos of a minus b. Or you can do one thing, you can send this to half over here. Means if you have cos a into cos b, then this is same as half into cos a plus b plus cos a minus b. And remember, cos theta is what? Cos is always even function. Means cos of minus x is same as cos of x. Or you can say if f of minus x is same as f of x, then we call this is even function. Okay, means cos theta is even function. Now let's combine these two. Okay, let's combine these two. You can combine anything. Here 0 to 2 pi cos of x into, okay, into half. This half I can send outside. Okay, here we have half cos a plus b. Here cos a plus b. Here cos 2x, we have cos 3x. 2 plus 3 is 5x. Cos of 5x, okay, plus a minus b. Here cos 2x minus cos 3x is cos of minus x. Okay, cos of minus x is cos x. So I can write only cos of x into dx. So this we need to multiply over here. This need to multiply over here. This same as half 0 to 2 pi. This into this is cos x into cos of 5x plus this into this is cos square x into dx is equals to half integral 0 to 2 pi. Here again we need to apply. Okay, here again we need to apply cos a into cos b is same as half of cos x plus 5x means cos of 6x plus cos of 4x this, and then plus integral 0 to 2 pi. What is cos square? Remember, we have cos of 2x equals to 2 cos square x minus 1. Therefore 2 cos square x is same as 1 plus cos of 2x. Okay, Therefore, these two I can send down. Therefore, instead of cos square x, I can write like this. Okay. So instead of this, I can write half 1 plus cos of 2x into dx. Whole half is there. Okay. So I will erase something so that I can have some space. I will send this half. Okay, and then we will integrate it. Is equals to this into this is here 1 by 4. Okay, 2 to the 4. Now integral of cos 6x is sine 6x upon divided x of 6x is 6. Okay, and then plus integral of 4x is sine of 4x upon 4, and limit is from x equals to 0 to 2 pi. Okay, and then this half I will send over here also. It's 1 by 4 plus 1 by 4. So integral of 1 dx is same as x plus integration of cos 2x x is sine of twice x upon 2, and the limit is from x equals to 0 to 2 pi. Sine of here 6 to the 12. Okay, 12 pi upon 6 plus sine of 4 to the 8 pi upon 4 plus 1 by 4 2 pi here plus sine of 2 to the 4 pi 2 is equal to sine of 12 pi also 0, 8 pi also 0, sine of 4 pi also 0. Okay, what we have is this becomes 0, this becomes 0. So we have 1 by 4 into 2 pi. This term we have, means if I cancel this, pi by 2. Okay, so pi by 2 is the required. Welcome back. This integration was asked by MIT Integration B Qualifier exam in the year 2019, and this is question number 1. The value of these integrations looks like is equals to 0. Why? Because over here 10 is what? 10 is odd function. And then what about cos? Say if we see in this over here 0 degree, here 90 degree, here 180, and here 270 and 360 degree, and here this is CS, here CS cosine, here 1 comma 0, here minus 1 comma 0, means what? Cos 0 degree is 1 as well as cos 360 degree also 1. Okay, similarly cos 180 degree is minus 1. Now from here to here is 0 to pi, and from here to here is pi to 2 pi. What I'm going to do is, instead of 0 to 2 pi, okay, and then I will break like this. So is equals to 0 to, I will break 0 to pi, tan of cos of x dx plus then pi to 2 pi, pi to 2 pi tan of cos of x into dx. Now let's keep as it is. Okay, here keep. We'll solve this. Okay, we'll solve this. Now for this I will substitute x equals to u plus pi. Why? Because I want to bring this, the integration of limit from pi to 2 pi to 0 to pi. When x equals to pi, then u tends to 0. When x equals to 2 pi, okay, then u tends to 2 pi, means 2 pi minus pi is pi. So the limit of integration become pi to 2 pi to, we have 0 to pi. Now let's differentiate this. Okay, dx equals to, we have this dx become du. So therefore this keep as it is for timing. We have plus integration become 0 to pi, and then we have tan of cos of, instead of x we have to write u plus pi and then instead of dx we have to write du. What is u plus pi? Okay, or you can say pi plus u. You can write also pi plus u. Doesn't have any, all are same. Okay. What is pi plus u? We have ASTC rule. Here, all in this first quadrant, all are positive. ASTC rule. Okay, means all sine, tan, cos. Now, what is cos of pi plus u? Okay, pi is over here. Plus u means in this quadrant. Okay, so in this quadrant, tan is positive. Therefore, cos will be negative. Okay, so since it is multiple of pi, so cos will go to cos. Therefore, we will get cos of u. Okay, therefore this. Okay, instead of cos of pi plus u, so I can write is same as 0 to pi. Just I am considering this part. Okay, I am considering this part. This as it is. This is tan of pi, tan of cos of. Here we will get minus cos of u into du. Okay, but remember we have tan is our odd function. Tan of minus theta is same as minus tan theta. Okay, so this minus I will bring out. So this minus I am bringing out. Okay, why? Because tan theta is our odd function. Okay, therefore this we have, remember this, look at this and this. So we have 0 to pi, we have 0 to pi, and tan of cos of x dx, we have tan of cos of u du. Okay, okay, therefore this and these two gets cancelled. Therefore the value of this integral become what? 0. Okay, the value of this integration become 0. Thank you for watching. Please like and share. Thank you for your support. Welcome back. This integration was asked by MIT Qualifier exam in the year 2019, and this is question number 4. Since we have 1 over here, 1 is same as 1 square. Okay, so we have integral dx upon a square minus x square. Remember we have integral upon 1 upon a square minus x square dx is same as 1 by 2a log of, it is minus, then plus a plus x upon a minus x plus some constant c. So I will use this formula over here. So this equals to 1 by, so instead of 1 I can write here 1 square. So 1 by twice a 1 by 2 into 1 is 1 log of, here a plus x, here 1 plus x upon 1 minus x, and integration limit is from minus half to half is equals to, we have half, substitute upper limit minus lower limit. Okay, here we have log of, here half. Okay, half plus 1 is 3 by 2 upon 1 minus half is half. Okay, this is upper limit minus lower limit log of minus half. Okay, here 1 minus half is half, and then here 1 minus plus half is 3 by 2. Okay, here 3 by 2, and these two gets cancelled, these two gets cancelled. We have equals to half and log of 3, log of 1 upon 3. Okay, log of 1 minus plus log of minus plus log of 3. Why? Because log of m by n is same as log m minus log n. Remember, log of m upon n is same as log of m minus log of n. Okay, since we have minus over here, so minus plus. So log 1 is 0. Log 1 is 0 over here. So we have log 3 plus log 3 is same as twice log of 3. So 2 gets cancelled. We have only log of 3. So this is the required answer for this. Thank you for watching. Please like and subscribe. Thank you for your support. Welcome back. This integration was asked by MIT Integration B Qualifier exam in the year 2019, and this is question number 5. we have 2 raised to log x. 2 is constant over here, and then limit is from 0 to 2. We have limit is from integral 0. We have 1 here. We have 2 over here. Okay. But this log x, okay, but log x is not continuous at 0 plus. Therefore, it is a improper integral. So this can be written as limit of, I will assign u here. Here u tends to 0 plus u, limit integral is from u to 2 and 2 raised to log of x into dx. Okay. And then we have one logarithm property, a raised to log of b is same as b raised to log of a, where a and b should be strictly greater than 0. Okay. Means a raised to log b is same as b raised to log a. Okay. This we have properties of log. What is this? Log property, logarithm property. Okay. So now if I apply this formula, so this is same as limit of u tends to 0 plus integral from u to 2, and I can write this is same as x raised to log of 2 into dx by this property. Okay. Therefore, this is same as, so we have this. So let's integrate this. Something like x raised to n. Okay, here log 2 is constant. So this is same as limit of u tends to 0. Integration of this is x raised to log of 2 plus 1, or we can say 1 plus, I'll write 1 plus log 2 upon 1 plus log 2, and then limit is u to 2. Okay. Instead of x, you have to substitute u, and instead of x, you have to substitute 2. Okay. Now let's substitute over here. Okay. Is equals to limit of u tends to 0 plus we have, and if I substitute upper limit means what? Instead of x, I have to substitute 2. Okay. So 2 raised to 1 plus log 2 upon 1 plus log 2 minus u raised to 1 plus log of 2 upon 1 plus log of 2. Okay. When u tends to 0, okay, now when u tends to 0, we have u over here. Okay, now whole this term becomes 0. Okay, so this doesn't affect when u tends to 0. Okay, so therefore we have only is equals to 2 raised to 1 plus log 2 upon 1 plus log of 2. This is the required answer for this. Okay. Thank you for watching. Please like and share. Thank you for your support. Cos x even function as well as sin x is odd function. We have, remember, minus a to a f of x dx is equals to 0 when f of x is odd function. Now this if fx is odd function, then integral of minus a to a becomes 0, and we have sine of x is odd function. Why? Because f of minus x equals to minus f of x, as well as cos of x is even function, means f of minus x equals to f of x. So these fundamentals we have to use over here. Okay. So now what I will do is I will multiply first. This equals to integral minus 2 pi to 2 pi. If I multiply this, we will have minus cos of 3x into sine of 19x, this into this, and then this into this, we have plus cos square 3x, and then this into this minus sine of 2x into sine of 19x, and then here plus sine of twice x and cos of 3x whole dx. Now look at here. Okay, in this sine is what? Sine is odd function and this even function. Okay, therefore odd into even function become odd, okay, because minus will come out, okay. Or you can check, you consider this f of x, you write f of minus x, you will get minus of f of x, okay. Therefore this odd function, and this is purely even function, okay. Here we have even function, and over here also odd function, okay. Here we have odd function. This also even function, because minus will come again, okay, minus minus plus, okay. Therefore this also even function. So this, the value of this, when limit is from twice pi to pi, this become 0, as well as this become 0. What we have is, we have only these two, okay. So is equals to, why? Because by this property, okay. Since this is odd, since it is odd, limit is from minus a to a, f of x become 0, okay. So therefore this equals to, we have only this integral minus 2 pi to 2 pi cos square 3x minus sine of twice x sine of 20 19x into dx. Now how to integrate this? Cos square, what is cos square x? Okay, here we have cos twice x is 2 cos square x minus 1. From here I will get cos square x. From here 2 cos square x equals to 1 plus cos of 2x upon 2, okay, cos square x. Now I need cos 3x, okay, so instead of x I have to multiply 3, okay. Therefore cos square 3x will be same as 1 plus cos 3 to the 6, okay, 6x upon 2. So instead of this I'm going to use this one, okay. And what about this? Okay, we have sine, we have to use sine a and b formula, okay. So we have sine of a into sine of b equals to, is equals to half cos of a minus b, half cos of a minus b minus cos of a plus b, okay. So I'm going to use this formula over here, and then this over here is equals to minus 2 pi to 2 pi. So cos square 3x I can write is half, so I can send half outside, half, so 1 plus cos of 6x into dx for the first term, okay. So minus integral minus 2 pi to 2 pi this, okay. Here also we have half, so I can send half outside, half, and then this is cos of a minus b. Here we have cos of a minus b here, okay. So this minus this is a minus b, okay. But remember cos of minus theta is same as cos of theta, okay. So if you subtract from here to here, here to here doesn't affect anything. So 17x minus cos of 20 21x, and then this is my dx is equals to half, and integration of this is, we have x, okay. So x plus integration of cos is sine 6x upon differentiation of 6x is, we have 6, and then limit is from minus 2 pi to 2 pi minus half, and let's do integration. Integration of cos is sine, okay. Here we have sine of 2017x upon differentiation of this is 2017 minus sine of 2021x upon 2021, and limit is from minus 2 pi to pi. Remember, okay, remember the values of sine of multiple of pi, okay. Multiple of pi means what? Is always 0. Remember, we have in this, okay. Here we have 0, here pi, okay, and then 2 pi, okay. Here cs, here 1 comma 0, here minus 1 comma 0 cs, okay. Sine 0 also 0, okay. Sine pi also 0, and whatever multiple of pi, okay, whatever multiple of pi, sine n pi is 0, okay. Therefore, what we have is whatever sign you have, all this becomes 0, okay. Therefore, this is going to become 0. This part also is going to have 0. We'll have equals to half. Here, upper limit minus lower limit means 2 pi minus of minus 2 pi, okay. We have is same as half, here 2 pi plus 2 pi is equals to 2 pi plus 2 pi is 4 pi upon 2 is 2 pi. Okay, this is the required answer. Okay. Thank you for watching. Please like and subscribe. Thank you for your support. Welcome back. This integration was asked by MIT Integration B Qualifier exam in the year 2019, and this is question number 8. Look at here, we have integration is from 0 to infinity, and we have 1 upon t square, okay, and differentiation of 1 by t is minus 1 upon t square. So now if I start from here, I will do some adjustment over here. This is same as 0 to infinity e raised to minus of square root of 2019 upon 40 same as 2t the whole square upon t square dt. Why I am doing this? Because if I substitute this equals to u, then differentiation I will get 1 upon 1 by t square, okay. So now let's substitute u equals to square root of 2019 upon twice t. Then my du will be differentiation. This is constant, so what I have, and 2 also constant, square root of 2019 upon 2 is cancelled, 1 by t. Differentiation is minus 1 upon t square into dt, okay, minus du into twice, okay, here this I will send down, square root of 2019 is equals to 1 by t square dt. Let's check once again. This minus I am sending outside, these two I am cross multiplying over here, these two down, okay. Therefore, this is here, okay. So this is same as, instead of this I can write like this. So what about limits? When t tends to 0 is undefined, means infinity. When t tends to infinity, something by infinity, infinity is very large number, okay. Therefore, this tends to 0. Therefore, u become 0. So, is equals to integral 0 to infinity become infinity to 0. Infinity is 0. And hold this, okay. This e raised to minus u square into minus du into 2 upon square root of 2019, okay. So is equals to this minus, okay, this minus I will flip the limits, okay. So 0 to infinity, this minus has gone, this minus has gone, and then these two I am taking outside, and this also I am taking outside. 2019, what we have is e raised to minus u square into du, okay. What about this, okay? What is this? Now integral 0 to infinity e raised to minus x square dx equals to root pi upon 2 by Gaussian integral, okay. This is by Gaussian integral. By Gaussian integral from 0 to infinity e raised to minus x square dx become is equals to square root of pi upon 2, okay. By using this formula, so what we have is equals to, what we have is 2 upon square root of 2019 into what we have is square root of pi upon 2, okay. So these two gets cancelled, square root of pi upon 2019, okay. This is the required answer for this, okay. Now for Gaussian integral, this proof you can see one of my videos, okay, one of my lecture. Thank you for watching. Please like and subscribe. Thank you for your support. Welcome back. This integration was asked by MIT Integration Qualifier B in the year 2019, and this is question number 10. We know that square root of x the whole square is x. For this integral, I will substitute root x equals to u, and let's see how it works. So I will substitute u equals to square root of x, then my u square equals to x, square root on both sides become x. Dx equals to twice u du, and what about limit? When x tends to 0. When x tends to 0, then u tends to 0. When x tends to 1, okay, therefore u tends to 1 is equals to 0 to 1. Square root of x is what? Square root of x is u upon 1 plus x. What is x? Is u square into, what is dx? Dx is twice u into du is equals to, these two I can send outside, 2, then u into u become u square upon 1 plus u square into du, limits from 0 to 1. Here we have 1 plus u square, so I can adjust plus 1 as well as minus 1. So this is same as twice integral 1 plus, so 1 plus u square, or you can say u square plus 1 upon 1 plus u square into du, minus we have 1 upon integral 1 plus u square into du, and limits from 0 to 1, 0 to 1. Now here 1 plus u square is same as u square plus 1, it gets cancelled, so we have only 1, okay. 1 into d integral du is become u, so is equals to twice what we have, only u we have, minus here we, and this is what integral of this is tan inverse u, and limit is from 0 to 1 is equals to twice upper limit minus lower limit. Instead of u, write 1 minus tan inverse 1. Okay, this is upper limit minus lower limit means 0. Here 0 minus tan inverse 0, okay, is equals to 2. 1 minus tan inverse 1 is 45 degree, okay, this same as pi by 4 minus plus tan inverse 0 is 0, okay. So here this same as 2 minus pi by, so pi by 2 will come, okay. So this is the required answer for this. Thank you for watching. Please like and subscribe. Thank you for your support. Look at this integral. In denominator we have large sum. Large sum means it is of the form a plus b. So if you expand this, so denominator will become large over here, okay. So what I will do is, I will do substitution, and I will try to exchange u equals to x plus pi by 4. Then what is my x? X equals to u minus pi by 4. Okay. Now what is my du? Du is same as dx. Okay. And what about limits? When x tends to 0. When x tends to 0, then u tends to pi by 4. When x tends to pi by 2, then u tends to 3 pi by 4. Okay. So let's substitute over here. This equals to integral become pi by 4 to 3 pi by 4, and sine of what is x? X is u minus pi by 4 upon sine of u into what is dx? Dx is same as du. Okay. So now here denominator becomes small. Okay. Here numerator become big. So now here I can apply sine a minus b. Remember, what is sine a minus b? Sine of a minus b is sine a cos b. If it is minus, then minus cos a sine b. So by applying this formula, what we have? Sine of u minus pi by 4 is same as sine of u cos pi by 4 as well as sin pi by 4 values are same because it's 1 by root 2. Okay, so here we have sine of u into 1 by root 2 minus cos of u into 1 by root 2. So if I take 1 by root 2 common, what we have? Sine of u minus cos of u. So instead of this, I can write like this. Is equals to integral pi by 4 to 3 pi by 4. 1 by root 2 is constant, so I will send outside 1 by root 2. This is same as sine of u minus cos of u upon sine u is there. So sine u upon sine of u into du. Okay. So is equals to 1 by root 2. Limit is only pi by 4. Okay. So pi by 4 to 3 pi by 4. So now I can separate this. Okay. This upon this and this upon this. Now if I separate sine u upon u, sine u upon sine u is 1. So I have 1 minus cos by sine is cot of u into du is equals to 1 by root 2. Let's integrate this. This integrate we have only u minus. Now cot of u is what? Log of sine x. Log of sine of u. Otherwise you can consider like differentiation of sine is become cos. If you are getting differentiation of denominator, if you are getting numerator, then that integration is log of denominator. Means what? We have log of sine u. Okay, and then limit is pi by 4 to 3 pi by 4. Okay, so is equals to, so upper limit minus lower limit is equals to 1 by root 2. Upper limit means what? 3 pi by 4. 3 pi by 4 minus log of sine of 3 pi by 4. This is upper limit. Okay, so minus lower limit is pi by 4 minus log of sine of pi by 4. Okay, sine of pi by 4 is 1 by root 2. Okay, so what is sine 3 pi by 4? Sine 3 pi by 4 is same as, in terms of degree, we have 135 degree. Okay, so 135 degree is same as 180 minus 45 of sine. Okay, so sine 180 minus 45 is in this quadrant, 180 minus 45 is in this quadrant. Sine is positive, so sine will go to sine of 45. Therefore these values are same. Okay, therefore this here minus plus, this and this gets cancelled. Okay, 1 by root 2 here, over here minus plus 1 by root 2 over here. Okay, so what we have is this. Okay, here 1 by root 2 into 3 pi by 4, and then here minus pi by 4 is equals to, if I subtract this, 2 pi by 1 by root 2, here 2 pi by 4. So gets cancelled. Here 2 is same as pi upon 2 root 2. This is the required answer. Okay. Thank you for watching. Please like and subscribe. Thank you for your support. This question was asked by MIT in the year 2019, and this is question number 18. Here what I will do is I will break this. So x raised to m plus n is same as x raised to m into x raised to n. So if I am using this formula, then this can be written as integral 0 to 2 x raised to x square into x raised to 1. X raised to 1 is same as x into 2 log x plus 1 into dx. So what I will do is I will substitute this as u. Okay, let's see how it works. Now put u equals to x raised to x square. Now here we have function raised to functions. Okay, in this type of differentiation, So we used to take logarithm on both sides. So by taking log on both sides, what we have? Log of u equals to log of x raised to x square is same as x square. I can bring down x square into log of x. So we have this log u equals to this. Now let's differentiate 1 by u into du upon dx is equals to, here I have to apply u into v rule. Here x square into d by dx of log x is 1 by x plus log x, differentiation of x square is twice x. So is equals to x gets cancelled. We have x plus twice x into log x. Therefore, u upon dx equals to u. I can send u here x plus twice x into log of x. What is u? U is this. Okay, so instead of u, I can write x raised to x square. Therefore, du equals to x raised to x square, x plus twice x log x into dx. Whole this become my du. Whole this become my du. When x tends to 2, what about u? Okay. When x tends to 2, 2 square is 4. Okay. So here 2 raised to 4 is 16. Okay. Therefore, when x tends to 2, then u tends to 16. What about when x tends to 0? What about u tends to what? When x tends to 0, we have 0 and 0 square. Okay. But is equals to 0, 0 into 0 square is 0. 0 raised to 0 is what? It's, let's see what is this. Okay. So in order to find this, I will consider L equals to limit of x tends to 0, something like x raised to x. Okay. X raised to x. Okay. Something like x raised to x is equals to, if I take log on both sides, log of L equals to limit of x tends to 0. If I take log on both sides, I will get x into log of x. Okay, so this x I can write like this, 1 upon x. We can apply L hospital rule. Okay, so now if I apply L hospital rule over here, so let's differentiate this. Limit of x tends to 0, differentiation of log x is what? 1 upon x, and then differentiation of 1 by x is minus 1 by x square. So if I bring up, what will get? Minus limit of x tends to 0, I will get x. Okay, when x tends to 0, this become 0. Log of L is equals to 0. This implies L equals to, by law property, L equals to 1. Okay, therefore in this case this become 1. So let's substitute over here. So limit is become from 1 to 16, and then whole this become my du is equals to u 1 to 16 equals 16 minus 1 equals to 15. Okay, so this is the required answer for this. Welcome back. This integration was asked by MIT 2019, question number 14. Let's see this integral. Sine of 20x, sine 19x, cos of 20x, cos 19x. We can apply sine c plus sine d formula as well as cos c plus cos d formula. So I'll write down what is sine c plus sine d formula. We have sine of c plus sine of d is equals to twice, if it is sine sine, then sine cos, twice sine of c plus d by 2, then cos of c minus d by 2, then cos c plus cos d, cos c plus cos d equals to twice, if it is plus then cos cos, cos of c plus d upon 2, cos of c minus d upon 2. Okay, so now let's apply this to formula. This is formula. So is equals to, limit is from 0 to pi by 100, here twice will come, okay, twice sine of 39x upon 2 and then cos of by 2 into x by 2 upon here 2 cos of 39x upon 2, again cos of x by 2, here dx. And this cos x by 2 and this cos x by 2 gets cancelled. Even 2 also gets cancelled. Integral 0 to pi by 100 sine of 39x upon 2 upon cos of 39x upon 2 into dx. We have this formula, integral 1 by x dx equals to log of x plus c. Means if you differentiate denominator, if you are getting at numerator, then that integral is log of denominator. Means what is differentiation of cos? Okay, second, what is d by dx of cos of 39x upon 2? It is differentiation of cos is minus sine 39x upon 2 into d by dx of this angle, means I will get 39 by 2. Okay, so I need what I need here this I need 39 by 2, okay, with minus, so that this differentiation become this. Okay, so this is extra. Okay, so this is 39 by 2 is extra. I like 2 by 39 with minus, because this and this gets cancelled. Here we have dx minus 2 upon 39 log of cos of 39x upon 2, and then limit is from 0 to pi by 100 minus 2 upon 39 log of cos of 39 by 2 into pi by 100 minus, okay, when x equals to 0, cos 0 is 1, okay, so log of 1 is become 0, so we have 0 over here. So this is equals to minus 2 upon 39 and then log of cos of 39 pi upon 200. Okay, so this is the answer for this integral.